Hello and welcome to today's chemistry class. For this class, we're talking about the concept of empirical formula and molecular formula. For this topic here, there are two key words there. The first one is called the empirical formula, while the second one is called the molecular formula. So let's try to discuss about the first one called the empirical formula. By definition, empirical formula is a formula that gives the proportion of an element in a molecule, but not the actual arrangement of atom. Right? That's the definition for empirical formula. Right? A formula which gives the proportion of elements present in a compound, but not the actual number of arrangement of atom. That's like the definition for empirical formula. Let's discuss the second concept called the molecular formula. A molecular formula is a chemical formula that gives the total number of atoms present in an element of a substance or a molecule, right? That's like the concept behind the empirical formula. So when it comes to the concept of empirical formula gives the whole number ratio of the component element. So note that empirical formula gives the whole number ratio of the component element. Second thing to note is that molecular formula gives the actual number of atoms present in a component element, right? Or perhaps present in a substance. All right, I haven't discussed definition of empirical formula and molecular formula. Let's discuss something important called the step to calculate empirical formula. What are the steps? Let's discuss the step in calculating empirical formula. There are about 4 steps to calculate empirical formula. The first one there is that identify all the elements that make up a compound. So the first task is to identify all the elements that make up a compound. The second one is that divide the given masses of the compound elements or their percentage composition by the relative atomic mass, which is a constant, right? That is the second step to calculate empirical formula. The third step is that divide each ratio by the smallest value, while the last one is that hence you have the empirical formula. So these are the steps, the 4 distinct steps to calculate empirical formula, which I've given you now. All right, aside knowing the step to calculate empirical formula, how do you get molecular formula? Note that empirical formula times n we always give molecular formula. So note that empirical formula times n we give molecular formula. By the way, what's n? How do you get n? This n is got by, how do you get n? Calculated to get n. How do you get n? To get n, the idea is that I will use the concept of calculated relative molecular mass multiplied by n is equal to the given relative molecular mass. So I have this. So the idea now is that after knowing your empirical formula, how do you get molecular formula? Note that empirical formula multiplied by n we give molecular formula. So how do you get n? We said you get your n by multiplying the calculated relative molecular mass and equate it to the given relative molecular mass. So it means that in a question whereby I'm told to calculate the molecular formula, it means that I'm expecting that in that question they must give me a value for relative molecular mass. All right, with all this concept here, let's okay, at this point, before we proceed, at this point also know that there's another formula for calculating relative molecular mass, molecular formula per se. So also know that molecular formula is got by multiplying 2 times vapor density. So note that another expression to calculate molecular formula is that you multiply 2 by given vapor density. This is like the stuff we need to be familiar with when it comes to the study of empirical formula and molecular formula. All right, with all this idea, let us solve some jam and wire past questions and let's see what we can do. All right, example 1 says find the empirical formula of a compound which on analysis yield the following as reaction masses: carbon as 2.0 gram, hydrogen as 0.34 gram, oxygen as 2.67 gram. From your results, find the molecular formula of the compound if its relative molecular mass, that is RMM, um, of the compound is 60 gram per mole. All right, first things first, how do you solve this question? My first task here is to list out the givens. So we said when it comes to calculating for empirical formula, what's your first task? We said our first task is to what? Identify the elements that make up of that compound. For the question there, I'm seeing carbon, hydrogen, and oxygen. Those are the elements that make up that compound. So first is first, I will start with what? Identifying the elements. So I'm given carbon, I'm given hydrogen, and I'm given oxygen. These are the 3 elements that make up of that compound. All right, the next task is what? I'll divide. Look at the step I gave you. The second step is that you divide each gram of the masses of the elements or their percentage composition. In this case here, I'm given the gram of carbon, gram of hydrogen, and gram of oxygen. So in some cases, they might give you the what? The percentage composition. But in this case here, I'm giving the gram. So what's carbon gram? Carbon, the gram for carbon is given as 2.0. Here is given as 0.34, and here is 2.67 gram. Aside after this, we said divide the given masses. This is mass by what? Their relative atomic mass, which is what? A constant. What's the relative atomic mass of carbon? That's 12. So I will divide them by their relative atomic mass. Let me note that for this question here, carbon is 12, hydrogen is 1, and oxygen is 16. So the relative atomic mass, the relative atomic mass of carbon is 12, hydrogen is 1, while oxygen is 16. So I have this one here. You should note this stuff. Some cases in exam it might not be given, so you should know how to get the relative atomic mass, right? Which is carbon is 12, hydrogen is 1, and oxygen is 16. All right, we said divide the given masses. These are the masses given. So I said you might be given masses or percentage composition, but in this case we are given the masses. So we said divide them by what? By their relative atomic mass, which is a constant. For carbon, I have 12 divided by 12. For hydrogen, I have 1 by 1. For oxygen, I have 16 divided by 16. At this point here, divide this by this. What do I get there? All right, if I divide this one here by this, I'll have about 0.17. For this one here, I'll still have 0.34, and for oxygen there, I'll have 0.17. We said after dividing through by the given relative molecular mass, the next step is what? Divide by the smallest ratio. Of course, I'm having 0.7, 0.34, 0.7. The smallest is what? 0.7. Divide through by 0.7, sorry, 17 per se, 0.17, 0.17. This gives 1, this gives 1, this one here gives 2, this one here gives 1. So the empirical formula is formed down. How? I have C, this becomes C. Next up, this is a 1, that's C1. Next up, this H, I have H. How many hydrogen? I have 2 hydrogen, H2. Next up, oxygen is 1. I have just 1 oxygen. So the empirical formula the empirical formula is given as what? CH2O. This becomes the empirical formula that I'm looking for, right? Now the question says we should also find the what? Molecular formula, but we are given a specific what's it called, relative atomic mass as 60 gram per mole from the question. So how do you get your molecular formula? We said recall that empirical formula multiplied by n is always what? The molecular formula. All right, empirical formula times n we give molecular formula. I've gotten my empirical formula, right, which is this formula here. So we said let's get n. How do we get n? We said to get n, the idea is that for n, to get n, calculated relative molecular mass. This compound here, I'll have to look for the relative molecular mass of the compound, right? So from here now, what do I get? I'll have that C, the what's it called? If you don't know how to look for, perhaps how to calculate for relative atomic mass, I'll drop the link to how to calculate for the relative atomic mass of a compound in the description of this video, right? So very shortly, I said let's get n. Let's get n. To get n now, right? I need to know. I'm looking for molecular formula, so I need to know n. I know this one already as this. Let's get n. We said to get n, calculated relative molecular mass. So for this CH2O, I'll calculate for relative molecular mass. For CH2O, I have carbon is 12 plus hydrogen is what? Just 1 multiplied by 2. Oxygen is what? 16. At this point there, if I proceed my solvings, what do I get? From here I will have 12 plus 2 plus 16. This will give about 30 gram per mole. 30 gram per mole, right? So this becomes 20 gram per mole. So I have 30 gram per mole as my calculated relative atomic mass. All right. So we said to get n, we need what? I need that value 30 times n is equal to the given is 60. Right. So how do I get that? All right. From here now, this is calculated relative molecular mass. I'll put its value here, right, multiplied by n, which is equal to the given relative molecular mass is 60. So how do we get n? We said that becomes 30. I'll have 30 multiplied by n is equal to the given relative molecular mass is 60. So I'll have 60 here. Multiply this to 30n is equal to what? 60 divided by 30 by 30, n is equal to 2. So my n is what? Is 2. So I'll put 2 here to get molecular formula. All right, if I put 2 here, so empirical formula times n is equal to molecular formula. From there, what's the empirical formula? That's CH2O. I have CH2O multiplied by n. What's n? N is 2. I have 2 is equal to molecular formula. From here, C times 2, that's C2. H2 times 2, that's H4. Then O2, which is equal to what? My molecular formula. So from here, molecular formula is given as C2H4O2, while the empirical formula is given as CH2O. So this is how to calculate for the empirical formula and molecular formula of a given compound. Next class, try to solve several other problems under empirical formula and molecular formula. See you in the next class.